Thank you. Good morning. So, uh, feels more like a stand-up setup, no? Doesn't feel like a whatever. I was wondering what to do right now. Anyway, welcome. Yeah, it's day 2. So my name is Harish, and I lead engineering at ACKO. And yeah, today the most relevant topic for discussion, of course, is AI and responsible AI. That is how we in Insurtech look at it, right? I mean, AI means a lot to many people. So let's start. And I know there's a clicker here. Okay, we can skip this. You know my name already, right? And I'm running this because I have my data point somewhere, right? So we'll begin with what is responsible AI, right? And I put it in this fashion. Responsible AI essentially means that using data ethically. So far, I mean, in my previous lab before ACKO, of course, with Flipkart, and back then we had India's largest data lake, right? Back then, in 2014-15, we were generating roughly about 30-40 gigabytes of data, in about half an hour. Every data, click, stream, the way you hold your phone, your swipes, your clicks, your left, rights, etc. So one is you collect enormous amount of data. The 3 V's as we call it, right? Velocity, variety, right? So how to use data ethically is what forms the foundation of responsible AI. Why we'll come to it in maybe a couple of slides more. What do you mean by ethically handling data, right? Ethical handling means that you securely handle personal data. The key point is being throughout its life cycle. So it's not just at the point of collection. It's not that you safely, securely somehow get it, but then you should be able to handle it both through ingestion, handle it at storage, handle it during intra-system transmissions, handle it when you hand it over to a model, right? Of course, when you do inference on top of it, then when you send it back to the customer, of course, it could be sending it via a chat mode, sending it via some other media. It could be bulk, for example, like in insurance, for example. We do a lot of bulk updates to customers saying, hey, here is where benefits are, etc. Right? And then, how do we achieve that? Critically, clearly, you first number one, you need to know and you need to collect only what you need, right? Now I don't know if you have ever given your phone number to somebody in some metro store, shoe store, somewhere in some mall. The next 20 days, you're going to get calls from random people, random companies you've never heard of, right? Because they're collecting what they don't need, right? And they don't collect when they need it. So the first step of responsible AI as an organization, corporate, is only to collect what you need, right? I mean, we're all data hungry. We're also data hungry, but it doesn't mean that you collect anything and everything about the user, right? Then there's a lot of it junk data. Just because storage is cheaper right now doesn't mean that you collect everything. Second thing is only when you need it, right? So even before you are able to see a code, they'll ask everything. Where do you stay? What is your phone number? How many people are in a house? Blah. I mean, you don't need it at that point in time, right? So being responsible means also being responsible on what to collect and when to collect. Yeah. And then the most important thing right now in the world of AI is ensuring fairness and transparency and accountability. We'll get into this in a little more detail. That's what my session is all about. And of course, at the bedrock of this, you have to implement data privacy regulations to ensure that you're always protecting the user, not you. It's not about if my data gets leaked, what happened to me? No, that is secondary. Primary, as an organization, as a corporate, as a technology guy, as an architect, as an engineer, you have to think about how do I protect users always first. Yeah, everything else comes in later. Right. So what data do we collect? Now I was just talking about being responsible and collecting as little as possible, but here goes. Is this not all what we generally collect? Right? We collect everything. Right? We collect customer data, non-personal. We collect, like for example, where do you stay? We collect streaming data, for example. Right? How do you click? How many times you visited the website? Right? What frequency did you visit the website? Did you scroll on the website? Did you look at the details page, etc. Right? Device metadata. What phone is it? We have this seen very often. There is all these things going around on the internet. That Uber is expensive on iPhone. It's cheaper on Android. You have all that, right, going around. Why? Because there is some device data, metadata. Is it an old phone, new phone? Does this user change phones very frequently? बहुत पैसा क्या इसके पास? Whatever, right? You're trying to collect all that, isn't it? Then environmental context data. For example, what is the weather today? It matters especially in insurance when you're doing, for example, insuring buildings and houses, etc. Right? Yeah, is it raining today? Suddenly has become very hot. Have they cut down a lot of trees in that area, etc. Right? Payment and purchase data, of course, you have to collect, you have to store it, because customers have paid you. You still try to collect what IP address was it paid from, when was it paid, etc., etc. Right? And then, of course, in insurance, let me take that use case. We collect data about the car. If you are buying health insurance, we collect data about your health. Of course, you collect buying life insurance, you collect data about, you. Then there's government data from other agencies, right? What is your credit score? What is this? What is that? Right? Then, of course, some proposal data. Who's in your family? What is your age? Are you healthy? Not healthy? Then relationship data. How many people are in your family? Right? And of course, some PII data about you. Right? So when you think about all this, just imagine the responsibility that comes with collecting all this data. Right? Some data is publicly available, like environmental data, government data probably is publicly available. Some data is not very harmful, like your device data is okay. I know you have an iPhone, I know you have some sort of Samsung, it's okay, it's not such a big deal. But more things like, for example, payment data, your proposal data, family data is very, very critical, right? You need to know how to safely, securely, responsibly handle it, right? So, yeah, I'm not moving it here. Right, I call this traditional simply because you have to understand how securely data was collected in the past. In the past, data was collected by somebody talking to you, right? Somebody is filling a proposal. A doctor is talking to you, try to get health data, not a doctor sitting in the garden, by the way. This is what best Ghibli could do. Anyway, and then people are collecting data, for example, via surveys, right? People are collecting data, for example, by talking to you. And so this environmental data collection, personal data collection, private data collection, etc. This is more, let's go back from there to what, how it looks like today. So I think a lot of you will connect to this particular slide, right? Where this is how we essentially collect data today, right? The most important thing to understand is not just collection of data, it is about enriching the data. That's what the enrichment layer inside is all about. What is enriching data? Enriching data is essentially connecting semantically two data points. I know this about you, I know that about you. How can I enrich that to understand more about you? People call it profile building, people call it something else. Profile building is a very specific term. It's only about the customer or the consumer. Enriching essentially means, can I, for example, connect day of time of usage with the device and understand whether this person is comfortable doing a certain activity sitting at home versus is the person comfortable doing a certain activity in the office or somewhere else, right? Is the person frequently on the metro? Is the person frequently, for example, again, way back in my e-commerce days, we knew that a lot of people between 6 and 8 are actually traveling when they are surfing the e-commerce website, meaning bus mein baitha hua hai, trying to look at what next to buy, right? So you're able to contextualize the data, and that's important, for example, when you do inference on top of it, right? Then, I think most of you already know this. Denormalizing the data becomes very critical before you send it to some AI engine, right? Why? The more context the AI system has, and I'm jumping the gun a little bit here, already introducing what we're trying to do, but the whole idea is to understand the more context the engine has, the better the inference is, right? For example, if you just tell the engine, here is the customer, here is the device, here is the date of time, here suggest, what should I tell the customer, for instance, versus saying, here is the customer, here is the device, here is the history of what this customer has told me, right? Here are all the other people probably, who need to be part of this particular context, right? Here is the external data for the particular customer, right? Here is the previous inferences for which, a certain output yielded better results. So when you contextualize all this, when you enrich the data, you bring it, all of them together in a very huge denormalized fashion, then better would be your results. Whereas responsibility come into it, we'll come into it at a second, because this denormalization essentially means that you are sort of connecting secure data, non-secure data, sensitive data, non-sensitive data in a large denormalized input format, right? That's where you have to figure out how much to get, how to get, when to get, how much to store, whether it is ephemeral storage or whether it is long-time storage, right? And how little to tell the model so that everything doesn't go in, but how much to tell the model. Yeah. So that's about then we can look at different types, or let me say, what's all again very critically important is, let's take a look at this, right? An event pipeline that also, for example, is getting in asset data or family data, right? Event data is essentially saying, did you switch on the phone, right? Did you come to my site or app? Did you click on this? Did you swipe? Yeah, did you click on whatever? That's event data essentially, right? When you marry that with the family data of for the particular customer, what you are getting is you are getting multiple POVs, as we call it, point of view. Yeah. Am I looking at the customer's conversion point of view? Am I looking at the customer's learning point of view? Like insurance, for example, some insurances, like health insurance, is a long-term consideration product. Meaning to say, people don't. It's not like it's not impulse you buy. It's not like you go to Flipkart. Oh, this is looking nice, 50% discount, buy. Nobody does it in insurance, right? I mean, you don't wake up to say, "Aaj mere ko insurance kharidna hai." Nobody like wakes up to do that, right? It's a long consideration cycle. People come in, they take a look at your site, they go to somewhere else, they do comparison, they ask a friend, they ask, that universal chacha at the house who knows everything, right? They go there, they take enough amount of time, right? Maybe months, and later they come back and say, "Here is what I feel is good." In that period, you've engaged with the customer, you've generated a lot of content data, both personal, non-personal, semi-personal, public data, you've brought all of them together. You have to create a POV on top of it, right? For the next interaction with the customer, what is my point of view of asking that, right? That's where the data pipeline again comes into picture, of course, and then, you need to have the ability to process both structured and unstructured data. What is unstructured data? For example, I can say, hey, give me your last year policy from some other vendor. I'll tell you how I'm better or not better, or am I good at it or not. That's sort of semi-structured data, right? Because I don't know the structure of what you have bought before. I don't understand the terms and conditions. I don't know the benefits that are currently there, right? So we'll spend a little bit of time on this. And at the end of the session, I don't know how much time I have. Maybe we will pause a little bit, maybe take questions on this slide. We'll revisit this slide later if anybody has. Yeah, so what does this mean? This is a very typical inference system, right? I mean, a lot of you have built systems like this. The key point that I'm trying to drive here is the following. The most important part is, of course, you have a bidirectional communication channel set up, with sockets, right? Which means to say that if you are especially in a chat mode, interactive mode with the customer, you ask the customer to send you something, ask something, basically request, you hold the context, and then after that, you have to send it back to the channel, in which the customer is talking to you, right? And sockets essentially do that, which means to say it is not a fire and forget sort of a mechanism. It is where you're in session with the customer. So we call each socket session, for example, as one context. And of course, there is a system that you'll have to build to manage that particular context, right? So what does this guy do? I just call it the context manager. You can call it whatever you want. While all engineers don't aspire to be managers, we love to use the word manager in every system, right? This manager, that manager. Nobody knows what the system does, but we name everything as a manager. Just to ensure that it is a wrapper, it is an aggregation technically, that does something. Yeah? More than one responsibility. Let me put it that way, right? A multi-responsibility component is always called a manager, technically, right? So a context manager just says, hey, I am now connected to the customer, and I'm now maintaining the conversation context, right? What is critical is to, for example, have a conversation cache. That is, I'm just calling it a cache. Essentially, it's both ephemeral and non-ephemeral storage. What it means is, how do I know what you have spoken to me before? I think 4 or 5 days ago, Sam Altman was talking about that ChatGPT will remember everything about your lifetime, if you know the latest news. What he's trying to say is, my next communication to you will be based on everything I know about you. So last year, at the same time, if you asked me a question, can I go to Thailand? The next year, if you ask me a question, and if you're like trying to find out if Bali is good, I have the context ki same time last year, bachon ke chutti ke time pe, you asked me the question about Thailand. So that entire context building, of course, it's different at that scale. But in your applications, it is sort of very beneficial if you have the conversation cache. Now, this is non-personal and semi-personal data here. Meaning to say, customer in the case of insurance might be asking, hey, my son or daughter, now suddenly became an adult, right, from 18 to 19. And let's say the policy does cover only kids. So what happens to this person? The customer is asking you, right, either on the text, chat, doesn't matter. The medium doesn't matter. So that context last year, so next year when you come back and say renew your policy, you need to have somehow that context that, okay, this family is now looking different, right? So it's sort of semi-personal data. Semi-personal meaning it's not so critical, to hold that at the same level as PII data. But it's also important to have that particular context, right? So having a responsibility at the time of maintaining the conversation cache becomes critical. That's the point I'm trying to drive. Yeah. Then you have a very typical agent system, which of course does 3-4 things that you guys are aware of. There's already a planning module, there's an intent module, right? There's a tool selector because any application worth its salt will have tools in it, right? Without the tool, what does the application do? Nothing. It is basically taking something and spitting out something else. The purpose of having the system is to ensure that certain things happen in the background, right? That the system is able to do something. And the do is usually your OLTP system, right? I mean, if I take, for example, payments, by the way, and I saw this Razorpay built a very nice MCP server. I don't know if you've seen the demo on YouTube, it's very nice. You can say, hey, make a payment on chat, and then I think it's on Sonnet, it goes and makes a payment, right? So effectively, if it doesn't do that payment, there's no point in having that entire application built, right? So you have your own tools that are able to essentially do something. Either they do something on the system of records, which is essentially CRUD services, usually REST, and of course, different SaaS clients, right? I mean, by SaaS, I mean anything that you have built yourself. Anything that is callable over an API, I'm just calling it SaaS at the moment, right? Then this is so far so good. Here, there's not much security that you have to include, except for the fact that your agent essentially knows what to call and is making secure calls across, right? I mean, we all assume that this is based on the Zero Trust API framework, that systems are able to talk with each other securely, etc. Only the data that has to be exposed is exposed, nothing else is done. The critical part comes where the RAG pipeline is getting built up. Today, of course, all of us build applications with RAG. Otherwise, it's very difficult to maintain that large context and, sort of tokenizing, embedding. The critical information here is the document sources. Let me put it the other way around. Your document sources are what you have to tokenize and keep, because there is no point in tokenizing your unique data, because that unique data doesn't really have that kind of embedding, right? I mean, why do you embed? You embed to ensure that you already have the distance, vector distance. So when you create the pipeline, send it to the LLM, it's able to do something, right? Your record and my record are very unique in the system, right? Every system, every record that is very unique, it doesn't help if you create embedding, because that embedding is extremely unique. Like me and my phone number are very closely connected, right? It's not like there are 10 phone numbers pointing to me, unless, I don't know, I'm like some very shady telemarketer, I'm using 25 phones, and all of that is in public data. That's not going to happen, right? So you need to create, or probably, at least I have seen this to be very useful, and hence, I'm putting it out here from my own experience. The embeddings are important where there's a lot of public information that you're putting in. For example, you're putting in data around how can I make a claim? It's public information, right? How does hospitalization work, for example, right? Hey, if I get hospitalized for a cataract, will the syringe cost be covered? Now, this is not specific to you or me, right? This is available everywhere else, right? This is, in my view, far more important. It is very beneficial, because the moment you take that, you put it in the embedding, then you take your personal data, connect it and send it to the context, very useful information comes out of it. That's where the responsibility of the AI comes into picture. You're not you really don't have to build a very secure RAG pipeline for public information or product information. What is product information? My product. It could be an insurance, it could be car. If you're selling a car, it could be your prospectus of the car. If you're selling something, a loan, it could be the details of the loan. It could be anything. You can sort of fill in the blanks with your own industry, your own product, your own company, and say, hey, what is publicly known about my company? Blah, right? That blah goes into your product information. That is not so important to be sort of managed very well. You don't need a lot of responsibility there, because it's anyway publicly available. Somebody goes on Perplexity and asks a question, probably it will do the same thing. It will give the same response, right? What is important is the document processing, vector embedding, building only on top of public data sources, and your agent is able to retrieve contextual, limited scope, obfuscated data. That is the critical piece. This is probably your own OLTP systems today, meaning your own systems, your company systems that have been running for 25, 30, 40 years. Could be an Oracle system, could be an SAP system, your homegrown system, could be your own e-commerce system, right? Could be your ordering, whatever. Because that has got a lot of personal information. It has got personal records of the customer. It has got a tokenization service example, for example, to tokenize what is only needed. At least in my view, the most important, is it coming up there? Okay. Because here the monitor is nice, I'm able to read it. I don't know if you can read it there. I'll read it out for you. So the arrow mark that goes from AI agent systems to data vaults, that arrow mark, the heading is called contextual, because it is contextual, meaning, what is contextual? Let me put it this way. By contextual, I mean, let's assume a conversational flow here, a chat flow here. In the conversational system, when the customer is asking a particular, let's call it a question at the moment, it's just a request. I know so many things about the customer, right? Do I need everything to answer this question? That's what is contextual, right? I may know everything about the customer. Do I need everything, for example, right? I mean, if let's say I'm doing e-commerce, or insurance is also okay. You say, I know that the customer has bought this and this, the customer's tiering is probably something, the customer's past record data is whatever. But the customer is asking me a question, for example, to say, hey, last time I bought shoes 9, now this is a new brand, I don't know whether shoe size 9 will fit, what do you think? It's a fair question for the customer to ask, right? Because that is typically a use case for an AI, it's not a search use case. So then you have to go back and say, hey, all these models, all the previous history, shoes history. Now you don't need the waist size of the customer, it's not relevant to this particular conversation, right? So you only pick up that segment of data responsibly again, and then you say, hey, now what do I know about all the models of that particular company? How have other customers reviewed to say size 9 here, guys, is not size 9. This shoe is slightly tighter, so maybe buy one size more. You'll have that, right, regularly on the e-commerce website. So that information is public. So that is public information. You have the shoe size of the particular customer and the ask of the customer. Contextually, I can call it a segment at the moment. Contextually, you only pick up that segment, and then you connect that with the public embedding of what you already know, and then the agent sends it to the LLM system. That's what the diagram is trying to say. So your responsibility comes into A, only getting what is needed securely, which means to say that you don't say get everything. Yeah? api.something.com/customers, customer ID is equal to 1, 2, 3, 4, get. You get like one dump of data, like some 10 GB of data or whatever, 5 MB of data. And then in that you loop through and figure out, oh, I need only this. But then what happens to that entire data it has gotten? You need to securely be able to keep, store. The agent has everything now, right? The reason why this is critical is if your agent is writing code to call a tool. If it's just making a call to another tool, then it's not so critical, because you know that even if you get a JSON of, I don't know, 5,000 lines, your post query to get something else is probably needing only 5, fields. Then you know what to map. But the agent is writing code, and agents do now, I mean, good agents do now, right? So your tool is also say, hey, write a code to get this from blah. Then you're passing the entire context of the customer into that write a code. And that has access to your entire customer data. That's where responsible AI comes into picture, right? Number 1, you contextualize it. And number 2, you understand what's in the context. Number 3, you sort of get only what you want, which means to say that your transaction systems also have to be built better. You need to write layers on top of it. Sorry, I didn't switch off my phone, my bad. Give me a second, all right. Yeah, we are good. So, which means you have to get that. You have to have systems to have only that. For example, your get API could be to say question mark, something is equal to blah. You're able to add a filter on top of it. That's the additional thing that probably you need to do, right? So, I mean, like I said, at the end, if you have time, we'll take questions. I have just 5 minutes. There's a lot of stuff to run through. Yeah. So, there's a large diagram here, but I only focus on 2 things, right? One is feedback mechanism, which is very critical. What is feedback mechanism? It refines the LLM prompts, yeah, using prior history. If the system had made an error in the past, you should be able to correct it the next time you do it. If a system went beyond the line, the last time it made a call, you should be able to correct it, right? And you should have the ability to read from your previous responses so that you're better. It's like meeting a person, right? The first time you meet a person, you have a conversation. The next time you meet, you have the context. You say, oh, this person is temperamental. I need to be softer. Oh, this person is funny, so I can go beyond the line. This person is very to the point, so I need to do the point. So you have the previous conversation in your mind. Agents are no different, right? So this ensures that if feedback mechanism, A is doing good. Number 2, how do you get transparency and accountability, right? See, it's very important that you have an evaluation model that checks for example, certain biases, equities, and representational accuracy. What I mean by this is, I'll sort of give you an example. Let's say the customer is making an auto claim and is conversing with me on something else, right? I need to be able to have that representational accuracy and bias to say the customer is in pain right now. I'm not going to sell the customer. The agent is not going to become salesy, right? Because I understand that my current bias towards the customer is one of empathy and not one of salesness, right? How do you do that? That is where you need to have systems in place. Now, the fairness check as a simple box looks nice, but then when you build it, it's fairly complicated. But the point is, we only have half an hour to discuss. Maybe if we have more time, we will go in more detail. I don't know, we can talk about it. But the point here I'm trying to drive is you need to have a box, yeah, where we're all out of time, I guess. I'll put three things. Intent, last outcomes have to be fed into the fairness system to ensure that your next responses are getting better and better and better. That's all, okay? Let's switch to that. I don't know how good it is on the monitor, but then I'll only talk about two layers. I'll not talk about the LLM and RG layer. This is very fairly common. ChatGPT will give you a much better example. Access layers you already know. There are essentially two or three. One is the socket-based chat interface, one is of course the batch interface, the other is your API gateways where you are connecting outside. We'll spend a little bit more time on two parts, data pipeline and which is the most critical thing. Number one, ensures that representation across demography. So your data is not really so narrow, that it only knows male 35 years IT. No, right? Or female 20 years, something else, doctor. It doesn't know, it's not narrow, right? That ensures that when your responses are going back, it understands contextually what is happening around, right? And if it is smart enough, for example, when all the blackouts were happening a couple of days ago, it doesn't tell you something very, very stupid or funny because people are under pressure there, right? So you have to understand that. That's what I mean by bias detection. You need to have proactive identification. The word proactive is very important here because it cannot be that the customer telling me, hey, you know what, this is not right. Please correct it, right? And then the most critical piece that we have to understand here is for balanced data splits in training and testing. Irrespective of whether you are only relying on the LLM to do it, when you pre-tokenize it, when you put it to the embedding, I think you should ensure that you are able to sort of get to know what to tokenize, get to know what to embed, and then embed it. Basically, you need another loop in between. That's what it means. I think we have only 3-4 minutes. Maybe I'll take a couple of questions if you guys are okay with it. Then we'll spend a little bit of time on what is this. The most important thing I want to talk about here is you need a decision explainability. You need to be able to store, log what you said so that you can human audit it later. See, once you get this is running on by itself, it's like a loop, but you should have the ability to, for example, log, store everything that has been reasoned. It is like explain that you do, when you use an agent, right? You say explain what you're thinking, how you log that thinking, because then later point in time, if there has been a bias, if there is an error, why it went wrong. Yeah, because the LLM is not a very deterministic system. The same question you ask it thrice, you will get 3 different answers, right? But at least you should be able to log and figure out to say what is happening, why did it make this particular bias, is there something wrong in my data, I'm asking it in the wrong format, is the history not getting sent appropriately, etc., etc., right? Of course, then closed loop improvement based on operational insights. This is where operational human beings are getting into the picture. They're trying to correct it. And there's a lot of content for half an hour, but then we'll try to see if we are able to do a good job. I have 1 minute. Yeah, cool. So let me just close with this. Every system determination should be explained and traced, which means you first have to log and audit it, number 1. Number 2, architecture should support emerging governance requirements. Today, the government may say do this, tomorrow the regulations may say do something else, right? Your architecture should essentially have the ability to support it. Bias prevention has to be there, and not only at the time of ingestion, not only at the time of calculation or inference, throughout the life cycle is important. So as long as you're able to put it everywhere else, filter checks, for example, this should work. So these multi-tier LLMs that right? I mean, you ask it, then there's another layer that checks, is this answer right to say or not? For example, continuous improvement process, this is okay. Of course, the critical piece, again, if you're building really responsible AI applications, you will have the ability to combine your batch input processing with real time to ensure that you're getting the same kind of an output, right?